Hello students, in this lecture I am going to discuss about the measurement of pH. So let me discuss what is pH. So it is a definition how acidic or alkaline a solution is for human beings. The taste of acid can be bitter, unpleasant and sometimes even inedible. So I'm telling you what is pH and what is the requirement of pH. Why do we need to know the pH of a solution? So we need to know the pH of a solution in order to determine the acidity or alkalinity of a solution. So what is acidity? Acidity is caused by an excess of hydrogen ions in a solution. We have a solution and the excess of hydrogen ions in a solution is the acidity of the solution. Normally hydrogen ions react with hydroxide ions to form water, but if an excess of hydrogen ions are present, then solution becomes acidic. So the hydrogen ions are released into the solution through dissociation of a chemical substance called an acid. Some of the most well-known acids are hydrochloric acid, sulfuric acid, acetic acid, etc. The whole pH range includes both acid and alkaline pH values, as you can see here. The scale of pH value is defined from 0 to 14. So pH values from 0 to 7 are in the acidic range and pH values from 7 to 14 are in the alkaline, or you can say base range. The pH value 7 is neutral, and you can see the that. So what does the pH value actually mean? So pH value is defined as the negative logarithm of the concentration of hydrogen ions in the solution. For a solution with a hydrogen ion concentration of 0.1 molar per liter, pH value is 1, since the negative logarithm of 0.1 is equal to 1. Therefore, for a whole range of pH values from 0 to 14, the concentration of hydrogen ion therefore varies from 1 mole per liter to 10 to the power minus 14 mole per liter. Now, why do we have this range of numbers from 0 to 14 for the pH value? And this is because of certain physical property of water. In water at 25 degrees Celsius, the concentration of hydrogen ion and hydroxide ions are related in such a way that the product of two is always 10 to the power minus 14. And because of this relationship, we can find out the concentration of one if we know the concentration of other. So for example, if the concentration of hydroxide ion is 10 to the power minus 7, then from the relation, the concentration of hydrogen ion is 10 to the power minus 7, and that will make the concentration of hydrogen ion into the concentration of hydroxide ion to be equal to 10 to the power minus 14. Now let's see. So these are the some pH values I have shown here. These are the pH values of some acid and some bases. Now let me discuss the method for measuring the pH for pH. So the method that we're going to use here, it is the electrode theory method for measurement of pH cell. So here you can see there are two electrodes. One is reference electrode and another one is measuring electrode. And this reference electrode, it is at constant potential regardless of whatever the pH value of the solution is under test. So there will be a beaker, and inside the beaker there will be a solution. Whatever be the pH value of the solution, the reference electrode is not going to get affected by that, and it is going to have a constant potential. Whereas measuring electrode, the potential of this electrode is determined by the pH value of the solution, and therefore the potential difference between the two electrodes depends upon the pH value of the solution. So the potential of this is constant, reference electrode. The potential of measuring electrode will depend on the pH value of the solution, and therefore the potential difference between the two electrodes will depend upon the pH value of the solution. Now let's see the construction. So this reference electrode, it is made of glass and it is having an inner assembly inside which there is a solution of calomel and mercury. You can see the solution of calomel and mercury is present in the inner assembly, and this assembly is surrounded by the larger glass tube, and the space between the inner assembly and the glass tube is filled up by this KCl, that is potassium chloride solution, and there is a tiny opening in the bottom of the electrode which permits this potassium chloride to diffuse very slowly into the solution under test. And in this way there is an electric contact which is maintained between this solution under test and the calomel solution of the reference electrode. The measuring electrode is also somewhat similar to the reference electrode. However, this measuring electrode, the mercury and calomel element is surrounded by a buffer solution. So there is a buffer solution inside between the inner assembly and the outer glass tube. There is a buffer solution. So this buffer solution is having a constant pH, and the bottom of the tube has no opening unlike a reference electrode, but it tapers down to a tip which is made of thin glass of special composition. There is a gel-like layer. Now at this tip a potential difference is developed between the buffer solution and the solution under test, which depends upon the pH value of the solution. Now therefore the net potential of this electrode is a function of the pH value of the solution under test, and both the electrodes, they are mounted to form an assembly that is inserted into the solution under test. So the difference of potential between the two electrodes is a function of pH value of the solution which is under test. So this is how we are going to measure the pH value of a solution. This is all about this topic. I am ending this class here. Thank you.